There has always been a silence in the night sky that feels deeply unsettling. When we look up and see thousands of stars scattered across the darkness, something inside us insists that someone, somewhere, must be looking back. Our intuition whispers that we cannot possibly be alone, yet intuition evolved to help our ancestors survive immediate dangers, not to interpret the structure of the cosmos. The universe does not operate according to feelings. It operates according to laws. Cold, mathematical, and indifferent to what seems emotionally reasonable to the human mind. Human instincts are powerful tools for navigating daily life. They help us cross busy streets, sense danger, and make split-second decisions. But when those same instincts are applied to cosmic scales, they collapse. The numbers involved in astronomy are so vast that our brains cannot truly grasp them. We are biologically wired to understand distances we can walk or drive. Even long flights stretch our imagination. Beyond that, the scale becomes abstract. Space is not merely big, it is incomprehensibly immense, and our intuition simply was never designed to process such magnitude. Consider Earth, a sphere roughly 12,542 kilometers wide. To us, it is everything: oceans, continents, civilizations. Yet on a cosmic scale, it is a speck of dust. We can circle it in under 2 days by airplane. That seems manageable. Now widen the lens. The sun lies about 150 million kilometers away. Light itself, the fastest thing in existence, takes over 8 minutes to reach us. If the sun disappeared, we would not know immediately. Even that delay hints at the immense distances separating objects in space. Now take another step outward to Proxima Centauri, the nearest star beyond our sun. It is 424 light-years away. The number sounds small until translated into practical terms. The fastest spacecraft humanity has built, the Parker Solar Probe, travels at roughly 692,000 kilometers per hour. At that astonishing speed, a journey to Proxima Centauri would take about 6,600 years. If you had departed when the Great Pyramids were completed, you would only now be arriving. That is the nearest stellar neighbor, and it already exceeds human historical memory. Expand further to the Milky Way galaxy, stretching about 100,000 light-years across. Crossing it with our fastest technology would require hundreds of millions of years. Entire species evolve in less time. The scale alone suggests an enormous barrier between civilizations. Even before considering technology or biology, simple distance isolates worlds from one another. The universe is not just large, it is structured in a way that separates stars by gulfs so vast they defy meaningful comprehension. Distance is the first verdict, and it is already overwhelming. Some might argue that the solution is simple: go faster, yet the second verdict is more unforgiving. The speed of light, about 300,000 kilometers per second, is not merely a technical challenge. It is a structural limit built into reality itself. It defines causality, the maximum speed at which cause and effect can propagate. Unlike the sound barrier, it cannot be broken with better engineering. It is woven into space-time. As objects approach light speed, physics resists more strongly, preventing them from ever crossing that ultimate threshold. Relativity reveals that as a spacecraft accelerates, its energy increases dramatically. Near light speed, additional energy does not simply make it faster, it increases its relativistic mass. The closer you get to light speed, the more energy is required for ever smaller gains in velocity. To reach the speed of light would require infinite energy. Not enormous, not astronomical, literally infinite. Even accelerating a grain of sand to that speed is impossible. The universe enforces this boundary without exception, for aliens and humans alike. Suppose we accept that limit and aim for a fraction of light speed. The third verdict emerges: the rocket equation. Rockets must carry fuel, and fuel has mass. To move that fuel, more fuel is required, creating an exponential spiral. For interstellar travel within a human lifetime, a spacecraft would need staggering amounts of propellant. Worse still, it must carry fuel not only to accelerate, but also to decelerate upon arrival. Every kilogram added increases the energy demand, compounding the difficulty beyond practicality. Even advanced propulsion concepts struggle under this tyranny. Chemical rockets are hopeless for interstellar missions. Fusion propulsion, though promising, would require spacecraft composed almost entirely of fuel. Antimatter, the most energy-dense substance known, remains fantastically expensive and difficult to produce. Generating sufficient quantities would demand energy outputs rivaling civilization's total resources for millennia. Any advanced society capable of such feats would also calculate the immense cost and likely conclude that interstellar travel offers poor returns compared to local technological development. Then comes the fourth verdict, biology. Human bodies evolved for Earth's gravity, atmosphere, and magnetic shielding. Deep space is saturated with high-energy cosmic radiation, capable of damaging DNA and increasing cancer risk dramatically. Shielding requires mass, which reintroduces the rocket equation problem. Microgravity weakens bones, shrinks muscles, and alters vision. Long journeys lasting centuries would compound these issues. Cryogenic preservation remains unsolved, as freezing cells causes destructive ice crystals. Generation ships introduce social, genetic, and psychological instability over extended time scales. Perhaps advanced civilizations are not biological but mechanical. Artificial intelligences and robotic probes might endure harsh environments better than flesh. Yet machines are not immortal. Radiation corrupts electronic systems. Micrometeoroids traveling at extreme velocities can puncture hulls. Materials degrade over time. Entropy spares nothing. Even the most robust spacecraft would face cumulative damage during voyages lasting thousands of years. Maintenance requires resources and infrastructure, which are absent in deep interstellar space. Longevity remains a formidable obstacle, even for machines. The fifth verdict concerns time and information. Humanity has broadcast radio signals for roughly a century, forming a sphere about 100 light-years in radius. Compared to the Milky Way's 100,000 light-year diameter, this is microscopic. For another civilization to detect us, they must be within range and listening at precisely the right frequency and moment. Signals weaken over distance and blend with cosmic background noise. The galaxy is vast, and synchronization between technological societies is profoundly unlikely. Civilizations are fleeting. Humanity's technological era spans mere centuries against a 13.8 billion-year cosmic timeline. The probability that two civilizations arise simultaneously, close enough to communicate and technologically compatible, is extremely small. One might have flourished near a nearby star a billion years ago, long before humans evolved. Another might emerge long after our extinction. Like fireflies blinking on different nights, civilizations may never overlap in time despite sharing the same galaxy. When these five verdicts combine, distance, light speed, energy constraints, biological fragility, and temporal misalignment, the silence becomes less mysterious. It may not signal emptiness, but separation. The universe's structure enforces isolation naturally. Travel is inefficient, communication uncertain, and coexistence improbable. The absence of visitors may reflect physics rather than absence of life. We must distinguish between emotional expectation and physical possibility, accepting that the cosmos does not prioritize our desire for companionship. What then of unidentified aerial phenomena? Extraordinary acceleration and maneuvering reported in videos often conflict with known physics. Rapid changes in velocity would impose immense g-forces, liquefying biological organisms and damaging materials. Hypersonic travel through atmosphere should produce shock waves and plasma trails. Yet many recordings show blurry shapes without such signatures. More mundane explanations, instrument artifacts, optical illusions, or human technology often align better with established physical laws than hypotheses requiring wholesale suspension of physics. Extraordinary claims demand extraordinary evidence. A civilization capable of overcoming interstellar barriers would command energy on stellar scales. Its arrival would not be subtle. Detectable disturbances in atmosphere, gravity, or electromagnetic spectra would be unmistakable. The absence of such clear signatures encourages skepticism. Mystery is compelling, but physics remains consistent. Until compelling, reproducible evidence emerges, caution is warranted. Wonder should inspire investigation, not abandonment of rigorous reasoning. Yet this conclusion need not breed despair. The same laws that limit us also stabilize the cosmos. The speed of light preserves causality. Energy conservation enables stars to burn predictably. Physical constants allow atoms to form and chemistry to flourish. Without these constraints, life itself would be impossible. The barriers that isolate civilizations are the same rules that make existence coherent. Structure gives rise to complexity, and complexity gives rise to consciousness capable of reflection. In a silent universe, Earth gains significance. If intelligent life is rare or widely separated, then our presence becomes profoundly meaningful. We are not awaiting rescue or invasion. Responsibility for climate, conflict, and progress rests solely with us. This fragile planet is our only confirmed home. Isolation can inspire maturity, urging cooperation and stewardship. Rather than diminishing us, the silence may elevate the value of our existence. We continue to search, but with refined methods. Scientists scan for technosignatures, unusual infrared emissions, laser pulses, or anomalous stellar dimming suggestive of megastructures. Curiosity persists, tempered by realism. Whether or not we ever make contact, we share common origins with any possible life, forged in stars, built from the same elements. When we gaze upward, we witness a universe governed by elegant laws. In that vast silence, our awareness itself is extraordinary, and for now, that is enough.